Have you ever tried to cut a thick piece of solid steel with a manual hacksaw? If you have, you know exactly how exhausting it is. Your arm feels like it will fall off, and after 20 minutes of furious sawing, you have barely made a scratch. It is incredibly frustrating. You just want to finish your project, but cutting the metal is holding you back. You see these massive iron cutting machines throwing sparks and slicing through solid steel like warm butter. You wonder how they actually pull this off safely. Today, we are going to break down the exact working principles of these incredible machines. Do not worry if you are completely new to tools. We will keep this very simple and easy to understand. At its core, an iron cutting machine is just a dedicated setup designed to bring a fast-moving cutting edge into contact with a stationary piece of tough metal. Strip away the plastic safety guards, and you are looking at three main components. You have a powerful electric motor, a spinning blade or wheel, and a secure clamping system to hold the metal perfectly in place. That is the whole secret recipe. The real magic happens in how those three things interact, specifically depending on the type of blade. Most machines use one of two main principles to get through iron. They either grind their way through, or they slice their way through. Let us talk about the grinding method first, as it is the most common in home garages. This grinding machine is usually called an abrasive chop saw. If you have ever seen a machine throwing a huge shower of bright orange sparks, that is an abrasive chop saw. The blade on this machine is not really a blade at all. It does not have sharp teeth like a traditional wood saw. Instead, it uses a large abrasive disc. Imagine a thick disc made of rough sandpaper, but the abrasive grit is glued together with strong resins and heavily reinforced with fiberglass mesh so it does not shatter under pressure. The grit is made of extremely hard materials, much harder than the iron or steel you are cutting. When you turn the machine on, the electric motor spins this abrasive disc incredibly fast. We are talking thousands of revolutions per minute. When you pull the handle down and press that spinning disc against your iron pipe, it does not actually slice it. Instead, the millions of tiny sharp rocks on the edge of the disc start slamming into the metal at high speed. Each little piece of grit violently tears away a microscopic flake of iron. Because the disc is spinning so fast, this happens millions of times a second, creating enormous friction. Now imagine rubbing rough stones against steel at thousands of miles per hour. The heat is intense, which is why you see all those sparks. These sparks are actually microscopic chips of iron heated by friction until they catch fire and glow white hot in the air. The abrasive chop saw essentially burns and rubs its way through the metal. It is a forceful, highly effective process. But there is another way to cut iron, using a completely different principle. This brings us to the cold saw. If the abrasive saw is a tough grinding wheel, the cold saw is a traditional saw, heavily upgraded. A cold saw uses a solid metal blade that has sharp, distinct teeth cut directly into the edge, engineered specifically for tough metals. The principle here is true slicing. When using a cold saw, the motor turns the blade much slower than the abrasive saw. It spins at a deliberate, measured pace, but it has an immense amount of turning power, known mechanically as torque. When you bring a cold saw blade down onto a piece of iron, the sharp teeth bite directly into the metal. Because it moves slowly with exceptionally high power, each tooth carves out a distinct little curling chip of metal and carries it away from the cut. It is literally shaving the iron away, piece by piece. You might wonder why it is specifically called a cold saw. Remember how the abrasive saw generates crazy heat and flying sparks? Because the cold saw cuts slowly and cleanly shears the metal rather than rubbing it. The heat is transferred directly into the falling metal chips rather than the metal bar itself. If you make a cut with a cold saw and immediately touch the metal piece, it will literally be cool. There are no sparks, no burning smell, and the cut is beautifully smooth. Whether the machine uses an abrasive disc or a cold saw blade, the power delivery remains exactly the same. You plug the machine into the wall, and electricity flows into a heavy-duty motor. Inside that motor, electric currents pass through copper wire coils, creating strong magnetic fields that constantly push and pull against each other, causing the central shaft of the motor to spin with incredible force. In some machines, this spinning shaft connects directly to the blade. This direct drive setup is simple and highly efficient. In other machines, the motor connects to the blade using a thick rubber belt and multiple pulleys. This belt drive system is clever because the belt acts like a natural shock absorber. If the blade suddenly gets stuck in the metal, the belt slips slightly, protecting the expensive motor from burning out entirely. One more crucial part of the working principle is the base and the vise. This might seem boring, but it is the absolute secret to why these machines work safely. When forcing a spinning blade through iron, the blade naturally wants to grab that metal and throw it. If you try to hold the metal with bare hands, the machine would instantly rip it away, which is incredibly dangerous. The heavy steel base provides a solid anchor. Attached to this base is the vise, a heavy-duty mechanical clamp. Before you make any cut, you place your iron stock against the back fence of the vise, and you crank the handle to squeeze the metal completely tight. By keeping the metal perfectly still, the blade can cut straight down without the material shifting or dangerously kicking back toward you. Let us put it all together and walk through the simple, step-by-step working process. First, you measure your iron and mark clearly where you want to cut. Then, you place the iron on the sturdy base and clamp it down into the vise as tight as it will possibly go. You immediately put on your safety glasses because flying chips and sparks are just part of the deal. You grab the handle and pull the trigger switch. This sends electricity into the motor, building up magnetic force and spinning the blade to full speed. You never push down right away. You always let the machine reach its maximum speed first. Then, you gently and steadily lower the blade down into the iron. If using an abrasive saw, the friction starts rapidly heating the metal, melting and tearing microscopic pieces away in a beautiful shower of sparks. If using a cold saw, the strong teeth start systematically shaving away ribbons of solid metal. You do not ever need to force it with your own body weight. The core working principle relies entirely on the speed and sharpness of the blade doing the hard work. You just apply steady downward pressure, letting the machine eat through the iron entirely at its own pace. Once the blade successfully breaks through the bottom, you release the trigger, the motor stops, the magnetic field disappears, and the blade slowly comes to a halt. You wait patiently for it to stop completely before raising the handle back up and unclamping your perfectly cut piece of metal. It is quite amazing when you stop and think about it carefully. We are taking raw electrical power from a standard wall outlet, converting it into rotational magnetic force inside a motor, and then using either extreme friction or high torque shearing action to casually slice right through one of the strongest materials on Earth. It practically turns hours of agonizing physical labor into a simple task that takes just a few seconds. Understanding these basic mechanical principles not only makes you a significantly better builder, but it actively keeps you entirely safe in the workshop. Subscribe for more tooltips and keep building safe.